All right, so today we're gonna kind of get into this next section 4.7, which is about graphing, okay? So we're gonna be taking some of these polynomials that we've been working on, and that we've been finding the zeros of, and we're gonna go ahead and graph them, okay? So we're gonna start off today by looking at something called end behavior, okay? What end behavior is it's how the graphs behave at the ends, okay? So let's go ahead and define that up here. Or actually, I'll just write it up here. How the graph behaves on the far left and far right, okay? So what's it doing at the far left and the far right? That is the definition of end behavior, okay? How the graph behaves on the far left and the far right. So to help us out with this, we're going to take a look at some of these graphs here. So right now, I wouldn't expect you to know necessarily what these all look like. Actually, the first two, you might know what they look like. Y equals X, and I'll go ahead and type it in here into Desmos. Y equals X is actually an mx plus b equation. It's got a slope of 1 and a y-intercept of 0, and so it's just a line there, okay? So it makes this line, it goes forever to the left, and it goes forever to the right. All right, good stuff. Now let's go on to y equals x squared. Now we graphed some of these last semester. This is our parabola, right? And this one is just a parabola right in the middle of the whole thing, right? So we can just draw our parabola just like that. Doesn't have to be perfect, just a quick sketch, okay? What I would like on both of these is the arrows. Notice that I drew arrows on both of those, right? So on the first one, my arrow is going down to the left and up to the right. On that second graph, y equals x squared is going up to the left and up to the right, okay? All right. Next up, let's do y equals x to the third. All right, so I have that in green here. If it's kind of hard to see, I'll take off the other two graphs so we can really visualize that. So this one's kind of a squiggly shape. I usually describe this as, it looks to me like an unfolded paperclip. You guys ever unfolded a paperclip and it kind of looks like that, correct? And so it kind of goes down really fast to the left and up really fast as it goes right. All right, let's move on to our next one then. Get y equals x to the fourth. Take a look at that one. I'd say that one actually kind of looks like y equals x squared, correct? It looks a little bit like a parabola. I'd say it's a little bit steeper. But generally speaking, that kind of looks like a parabola, yeah? So I have arrows going up to the left, on the left side and up on the right side as well. All right, let's do one more here. Y equals x to the fifth. And that one, I would say, looks very similar to the y equals x to the third, right? I'd say that looks like another one of those little unfolded paper clips. So let's draw a quick sketch of that. It's probably steeper than that. Actually, let me redo that. Yeah, okay, that's a little bit better. Okay, now I want to kind of back out here and look at these first five. Okay, and I want to fill out this little box down here, sketch the general form. If we have a positive x, I notice right away that there's kind of a big difference between all the odd exponents and the even exponents, correct? Don't the even exponents look kind of similar out of that group? And then don't the odd exponents all look kind of similar out of that group? I would say yes, okay? And I am including this first one is an odd exponent because remember when we have y equals x, that's really y equals x to the first, right? And 1 is definitely an odd power or an odd number, right? So let's keep that in mind. So if I'm going to sketch a general form of an odd exponent with a positive x here, I notice that in all the first power, the third power, and the fifth power, all of those odd exponents, it goes down to the left and up to the right, okay? On every single one of those. On the right side of the graph, it's going up. If you look back at the first power or the third power or the fifth power, and on the left side of the graph, it's going down. We notice that here for the first power, we notice it for the third power, and we notice it for the fifth power, okay? Now, for the even exponents, so that would be x squared and x to the fourth. All right, we notice for those ones, when we have the positive x, that it goes up to the left and up to the right. On both sides, left and right, it's going up, yes? So we can that's actually true for all even exponents when we have a positive x value, okay? It's going up to the left and up to the right. And that down to the left and up to the right is true for all odd exponents, okay? Okay, now this does change here if we have a negative x, all right? And if you look at our next 5 graphs, we're gonna look at what happens when we have a negative x, all right? And it looks like it's still gonna be broken down as odds versus evens. So try to be kind of aware of that as we're filling out these graphs, okay? So let's start off with help from Desmos with this one. So we get y equals negative x to the 6th power. Well, what is that one? I'd say that looks like an upside down parabola, correct? It is a slightly different shape. Again, it's a little bit more steep. But generally speaking, it looks kind of like an upside down parabola, okay? All right, let's try out y equals negative x to the 7th now. Now that one to me looks like one of those third power or fifth power little unfolded paper clips again, right? Except that it got flipped. So now it's going up on the left side of the graph and going down on the right side of the graph. So we can really see the contrast there between the negative x to the 7th and the x to the 3rd. It's just on the other side of it, okay? That's not really because of the 7th power. That is because of the negative in front. Any predictions as to what the negative x to the 8 is going to look like? I'll let you guys think about it. Well, if you were thinking another upside down parabola, you were correct, okay? So what we're starting to notice here, again, as kind of expected, is that the even exponents really act all the same, and the odd exponents also act all the same, okay? So with that logic, we should be able to predict negative x to the 9th power. I would say it just looks like that negative x to the 7th power, and you can see that it does. And lastly, just for fun, although I'll bet you guys know what this is going to look like, y equals negative x to the 10th power will give us that upside down parabola again. All right. Awesome. So I'm gonna go ahead and full screen this because we'll be done with. Oh, we'll check back with Desmos in a little bit here, but we'll be done with it for a while. So the general form then for an odd exponent if it's negative. All right. So odd exponents, I'm looking at the 7th power, the 9th power there. When they're negative, is going to be up on the left side and down on the right side. Whereas an even exponent, if it's a negative out front, will be down to the left and down to the right. So we kind of have 4 possibilities there, okay? So anytime we're doing one of these problems, we're going to want to look back at this chart right here. I'd say this chart's going to be kind of key for us. And so we're to decide, is it positive or negative? And then is it odd or even, okay? Okay. All right. Awesome. As x decreases. Okay, so we're going to be drawing arrows here, okay, to describe our graph, but we're also going to learn kind of some fancy math speak for how to describe these as well, okay? So as x decreases, we are going to say x goes to negative infinity. All right, and let's add this up here. So as x decreases, I'm going to call this left. So both of these are left. If you think about x going to negative infinity, all right, and that there is such thing as a negative infinity, where are the negative x values? Aren't the negative x values to the left? Yes, they are, okay? So there's 2 possibilities that could happen here. It could go down, or it could go up. So down would be y goes to negative infinity. And y here would be positive infinity. Okay. Oh, and here would be, I don't want to fill that out. Don't worry about that middle spot, okay? All right, now over here, we're going to do to the right, a la derecha. So both of these, if we're going to the right, x is going to be a positive infinity. But if we're going down, y is still going to be negative infinity. But if we're going up, y is going to be positive infinity. Okay. All right, so let's take a look at some practice problems here. Or let me wait like 15 seconds in case you need to get caught up. Okay, so let's take a look at some practice problems here. We're going to sketch end behavior of each polynomial based on their degree and their leading coefficient. All right, in standard form, which we're going to start off here in standard form, the degree is the biggest exponent of x, okay? So for number 1 here, I'm going to say that this one is degree 10. Why is it degree 10? Because the biggest exponent is a 10. I'm going to remind myself that that's an even number, correct? All right, next thing we need is leading coefficient. So the leading coefficient is the number out front. So in this case, that's -3. Now, all I care about is the fact that that's negative. Okay, so I have an even negative, okay? Even negative. Degree 10, leading coefficient -3. So I'm going to go back up to my chart. Even negative was this fourth box over here, correct? So I'm going to draw a quick XY plane. I'm going to draw down to the left and down to the right. However, I also want to describe this, okay? So how I describe it, I'm going to describe it in English first. So we go down left and then down right. But now I need to translate that to like these math speak with the infinities, okay? So down is referring to y. Remember, up and down is y. And down would be negative. So y arrow negative infinity as x arrow. And so left is x and is x and it's x negative, okay? Once again, just think about the numbers on your graph. Aren't the x values on the left, those are the negative ones. The x values on the right, those are the positive ones, okay? Now I'm going to do the down to the right. So this one will be y goes to negative infinity again. So down is always y to negative infinity. And then right would be x goes to positive infinity, all right? Okay, so that was a lot of info, correct? So we're going to keep practicing on that. I know that might have been a little bit overwhelming, but stick with us, okay? We're going to look at a bunch more of these. If you do have any questions, please feel free to write them in the chat or go ahead and unmute yourself. You can ask me too. All right, let's take a look at number 2 then. So number 2, let's take a look at the degree. I'll give you guys a second to think about it. All right, does anybody want to type in the chat? What's the degree on this one? Nice job, Kimberly. I agree. 3. And I like that you pointed out, in what's more important than the fact that it's actually 3 is that it's odd, correct? That's all we really care about, is that it's odd, but it is in fact 3 because the biggest exponent is 3. Okay, I'm going to abbreviate this LC now, since we know that means leading coefficient. So the leading coefficient on this one, I would say, is -4, which we know, more importantly, is the fact that it's negative. So for the degree, I care whether it's odd or even. For the leading coefficient, I care if it's positive or negative. Okay, so now we're gonna go back up to the chart here, okay? I will tell you guys, I have this chart memorized. If you guys don't, that's fine, because we're allowed to use notes on the quiz, right? Or test. So always look back at this chart. All right, we have odd, negative, so that's this third one right here. So that is up to the left, down to the right. So that's what our graph's gonna look like. Now let's translate it into the fancy math speak. All right, so up we know is referring to y, and up would be positive for y. X is referring to, sorry, left is referring to x, and we know x is negative if it's left. Down is referring to y, and we know down is negative for y. And then right is referring to x, and it's positive for x. I'm gonna go ahead and type this one into Desmos here. All right, so if I zoom out here, it's a pretty steep line, but I think you can see on the left side of the graph, it is going up, and on the right side of the graph, it is going down, which is what we drew on our graph there. All right, let's do a couple more here. And then we're gonna learn something a little bit new, but it's still related. All right, so for number 3, let's take a look at the degree and the leading coefficient. So for this one, I got a degree of 4, which is of course even. Once again, the degree is the biggest exponent in this form. We have the leading coefficient is 10, which is of course positive. All right, so we can go back up to our chart if we don't remember it. We got an even positive here. So we know an even positive is going to be this second box right here, even exponent positive x. All right, so that's up and up. Let's practice our infinity writing here. So I'm just going to write it in plain English first, up to the left, and also up to the right. Now we'll translate it to our math speak. So up is referring to y. It would mean y is positive. So just remember, up and down is y. Up is a positive y, down is a negative y. Left is a negative x. Right is a positive x. So we said left is a negative x. This one up will be y positive infinity again, otra vez. And now we have x is also positive. All right, not too bad, right? Especially if you have that chart, you just keep looking back at that chart for your reference, okay? All right, let's do one more of this type. And like I said, we're gonna learn something a little bit different. Okay, so number 4 here. So for this one, the degree is kind of tricky. I think you should know. But it might be a little tricky. It's actually an invisible exponent. Do you guys remember what the invisible exponent is? All right, how about in the chat? Can anybody tell me what the degree is on number 4? Oh, all right. I'll tell you then. This one's degree 1. So remember when you have no exponent on your x, that's really kind of the first power of x. So we're going to call that degree 1, which is in fact odd. The leading coefficient here is 4, which we know is positive. All right, let's draw our graph here. So where the arrows are going to go, I'm going to go back to my chart up here. So we had an odd degree positive. So that's actually the first box there. So we got down to the left and down to the right. Sorry, down to the left and up to the right, excuse me. Okay, so we know down is y negative. Left we know is x negative. Up is y positive. And x is also y positive. Nope. Right is x positive is what I meant to say there. All right. So we saw examples of all 4 there, correct? Okay. All right. Now a little different here, but not really, okay, is we're going to have to start looking at factored form. So what's factored form? That's when you have a bunch of parentheses multiplying, okay? On all of our previous questions, we had no parentheses in our equations, right? Just a bunch of terms listed out. Now, when you have the parentheses multiplying, very important here, the degree is the sum of all the powers, the sum of all the powers. So what is the degree on number 5? Well, remember, if we're missing any powers, that's really the first power. So if any parentheses are missing powers, I just throw a 1 there, okay? So what's our degree on this one? We'll have to add up all those exponents. Add up the exponents. 1 plus 1 plus 2. I'm getting degree 4 there, okay? So a little bit more work on this one to find the degree as opposed to the standard form. You just look at the leading coefficient, but really it's not that much more work, correct? All right, our leading coefficient here we really just look in front. I'm actually going to say this is 1 because there's actually an invisible 1 right there. What's more important here is that it's positive, obviously. So you can see an example on number 6 of what it's going to look like if the leading coefficient's negative. If you got a negative in front of your parentheses, that's going to be a negative leading coefficient, okay? All right, let's just sketch the graph on this one. So we have degree 4 positive. Look back at the chart. That's an even positive. So that's my second box there, up to the left, up to the right. There we go. Boom. All right, let's not worry about the infinities on this one in the interest of time, okay? Nice and easy. The arrows are honestly more important to me at this point. We will have maybe one question on the infinities, but the arrows are going to be very important, okay? All right, so let's take a look at number 6 then. I have one missing exponent, so I'm going to throw a 1 up there. So what's my degree here? Well, I have to add up all the exponents. 3 plus 1 plus 2 is going to give me 6. All right. Next up, we talked before how the leading coefficient here is negative, right? It's technically -1, okay, because there's no number out front. But what's more important to us is that it's negative, correct? All right, let's draw our arrows. Danny, right? Danny? Let's draw our arrows here. We got a degree 6 negative. So degree 6 negative, you can look back at the chart if you want. I know that since that's an even degree 6, it's actually the same as the even degree positive that we just did, except the opposite. So it's just down to the left and down to the right. So I kind of used my knowledge on the previous question. I know the even degree is up and up. So the odd degree is just the even degree negative is just the opposite of that. If you didn't remember that, that's fine. You can always look back at the chart, right? That's the key. All right, 2 more down here I want to get done, and we're getting through these really quick now, so let's keep going. All right, a little different though. Well, first of all, I'm going to fill out my missing powers. The degree here, since I have this x squared out front, I have to count that one, okay? When I'm adding these up, since I have an x there out front, I have to count these 2, okay? It is an exponent, correct? And it's an exponent of x. So 2 plus 1 plus 1 plus 1 is going to give me 5. So once again, I'm adding up those exponents, but I am counting 2 for that x squared out front. The leading coefficient here, I'm going to say is 3, which more importantly is positive. All right, so degree 5 positive. And look back at the chart. So we got an odd degree positive. So positive odd is down to the left and up to the right. Okay, lastly, number 8, we'll wrap this up. Well, I got a missing power right here on that parentheses. So my degree here is going to be 1 plus 4 plus 2. That's going to be a 7. Now, I'm not counting anything for the -5 out front. Why am I not doing that? There's no x there, okay? If there was an x there, I'd have to count it. No x, don't count it, okay? The leading coefficient here you can see is -5. So we have an odd negative. I could look at the chart or remember When you have an odd negative, it's the opposite of an odd positive. We have an odd positive over there. So like I said, it's the opposite of that. So you can just kind of use your own work to get to that conclusion, okay? Awesome. Okay, so like I said, I'll post a video with these notes. If you missed anything, you can go back and do that. And let's just submit those some point today. And we'll get some points for them, okay? And we have more notes coming tomorrow. All right, I think that's all I got. So if you guys don't have any questions, then we'll see you tomorrow.